Hello everybody. In this video I'm going to show you how I made a device to log into my computer using a fingerprint sensor. I'm going to demonstrate how to make it work on a Windows system, but you can apply the same process to any device as long as you have the login details. I think this is a really cool project, so without any further ado, let's jump right in. I want the system to be activated by tapping, so the first component we're going to need is a capacitive touch sensor. This one is fairly generic and is also quite sensitive, so you don't have to tap it too hard to get it to work. The next thing we're going to need is an Adafruit fingerprint sensor. I've chosen this one because it is fairly easy to use and also very widely available. We're also going to need a 3.3 volt regulator so that the fingerprint sensor can work with our Arduino Pro microboard. Speaking of the Pro microboard, for this project, this microcontroller is much more appropriate than, for example, an Arduino Nano. And the reason is that the Pro microboard is recognized by your computer as a native USB device. And that means that we can use the Pro microboard to emulate something like a keyboard or a mouse. And that's exactly what we are going to do. I thought it would be really cool if the fingerprint sensor module kind of came out from the bottom of my desk after detecting the tapping event. So to do that, I'm going to be using a gear system together with an SG90 servo motor, and we're going to put all this together using some 3D printing. Before making the 3D model, it's a good idea to make 2D sketches of all the components and their main dimensions. This helps to avoid modeling and 3D printing errors that can end up wasting a lot of time and material. Once the measurements are in hand, I normally just improvise the 3D modeling. The objective is to make sure that all the components have enough space to fit together, but without making the 3D model too big or too small. With the 3D model ready, the next step is to 3D print it. I decided to use a stone-colored PETG filament to give the final product an interesting and sort of quirky look. Let's go ahead and assemble this thing. So far, I think the model is looking pretty good. It fits together well, and I'm using a servo motor tester module to move the gear back and forth, and the fingerprint sensor module is moving exactly the way I imagined it. We are now ready to build the circuit for this, so let's go ahead and do that next. Here is the circuit diagram for wiring up all the components. The only challenging part here was wiring up the Adafruit fingerprint sensor module because the wires have different colors to the ones on Adafruit's official webpage. But I managed to figure out which wire is which based on their positions on the sensor's circuit board. With the circuit diagram in hand, building out the breadboard version is fairly straightforward. I just had to make sure that I get the pins right on the voltage regulator, which I did with the help of the pinout diagram. And now that the circuit has been built, we can finally program this thing. I started off by asking ChatGPT, of course, but I quickly learned that I had to do some parts myself. It did get some parts right, but it couldn't get the fingerprint enrollment stuff working together with everything else. Thankfully though, Adafruit has preset sketches for that, so I just had to use those in conjunction with ChatGPT's code. The way the whole system works is as follows. First, the touch sensor needs to be triggered so that the fingerprint sensor module is pushed forwards. Then, when a fingerprint is successfully read, the fingerprint sensor retracts back to its original position. And at the same time, the Pro microboard first emulates a mouse by clicking on the Windows logon screen, and then emulates a keyboard by typing in my Windows pin number, which is 2291. All of this functionality is hard-coded into the Arduino program. Now we can plug in our Arduino Pro microboard, upload the code, and we're ready to test our build. After lightly tapping on the touch sensor, the fingerprint module moves forward nice and smooth. And once it recognizes a fingerprint, it moves back to its original position exactly as intended. So, it's working pretty good so far. Our next task is to create the PCB. This process starts off by making a schematic diagram that will help turn our breadboard version of the circuit into a suitable format for PCB making. There's lots of software out there that you can use. I personally prefer Altium Circuit Maker because it comes for free, which is nice, and it's great for making all sorts of circuit boards. Now that the schematic design is ready, we have to go ahead and route this board up. Circuit Maker has an awesome auto routing feature which makes it super quick to generate routings, but unfortunately that won't really get me much watch time on my videos, will it? So I decided to go ahead and do it the long way. There's a lot of back and forth that happens when you're routing boards manually like this, but if you stick with it, it should work out okay. Once the routing is done, I take the design over to Adobe Illustrator and prepare the artwork for PCB making. This process takes a bit of time, but it really makes the vinyl transferring part of the process much easier. And now we get to the fun part, making the actual PCB. This process starts by taking a sheet of adhesive vinyl and cutting it to the right size. This is then prepared and fed into a vinyl cutting machine, which will cut out the design that we just made a few moments ago. Next, we need to peel off the vinyl to make the positive image. The easiest way to do this is by placing the piece on a backlit screen so it makes all the cuts easier for you to see. This process requires very careful attention to detail because you have to make sure you don't accidentally peel away things that you actually need. And trust me, I've done that loads of times. Speaking of which, I actually had to do this whole thing again once more off camera because I accidentally removed the border around the PCB. So here it is after doing the same process once more. Now we can take our vinyl positive and stick it onto the copper PCB. Before sticking it on though, most boards require some light abrasion and cleaning with alcohol so that the vinyl can stick on with enough strength. Once the PCB is nice and clean, we can stick on our masking tape and vinyl. It's important to get the alignment right because I will be putting this PCB into a 3D printed drilling jig to be able to drill in the holes that we are going to need to insert the components. When you're confident that the vinyl is stuck down properly, you can carefully start peeling off the masking tape. Now we need to cut our PCB to size, and we can do this using the vinyl border. My method of doing this probably wouldn't pass any health and safety checks, but that's probably why I don't have an actual job. So don't try this at home, okay? Just don't do it. Because the bandsaw blade is quite thick, sometimes I also have to come in with a grinding machine just to get rid of those little slithers on the edges that are too small for a blade to cut through. I made this jig so that we can slot the board in and drill the holes with the copper side facing up. It's important to drill into the copper surface. I use a small drill press to drill out all the holes on the board. This requires quite careful work because it's very easy to damage your circuit board and drill bits if you apply too much pressure. So here's the result of all of our hard work. It looks pretty good, I have to say. We don't need the border anymore, so I can just peel that off. It's not perfect by any means, but the holes are lining up good enough with the pads to be able to make a working PCB. We are now finally ready to etch this board. I use a mixture of hydrochloric acid and hydrogen peroxide. Once we've got enough fluid in the beaker to cover the board, you can gently lower it and press it down so that the mixture covers the board surface completely. Then you just have to wait for the etching process to complete. It's actually quite interesting to look at. I mean, there's something strangely addictive about these bubbles. Anyway, once the bubbles stop forming, it's a good sign that the etching process is complete, so you can go ahead and remove the board. The last step before soldering all the components onto this board is to remove the vinyl traces. If all goes well, this should reveal nice clean copper traces underneath. And that's looking quite good. I'm now going to stick the board cover that I designed earlier. Not only does this make the PCB look professional, it also helps you make sure that you put the components in their right places. And now we can place all of our components onto the PCB and start soldering. I've put female header pins on the board in case I need to remove or replace it. I also attached male header pins for the servo motor. Next goes the 3-volt regulator, then the touch sensor, and finally another set of female header pins for the fingerprint sensor module itself. With that out of the way, now it's time to solder everything up. I find it very helpful to do this under a magnifying glass because it makes the component legs easier for me to see. And finally, we can integrate everything now with our newly made circuit board. This step is nice and easy because everything is made to measure and the circuit board is labeled properly, so I know where to connect everything up. Now it's time to install this on my desk and get it to work. I think a good place to install it is right under the mouse pad area, kind of over here. So after sticking it down with some double-sided foam tape, although it looked okay, I sort of felt that it's lacking something, like something is just missing. Maybe there should be some kind of a warning sign. So I went over to Google and had a look at some warning signs, and I found a couple of designs that I thought looked kind of cool. This one in particular is really good because it looks kind of dramatic but funny at the same time, especially because we're only working with about 5 volts here. So I'll probably end up going with this one. And after redrawing a couple of ideas in Adobe Illustrator and printing them out, I definitely felt that this design looked better out of the two, so I cut it out, stuck it on my desk to see how it all looks, and I think that's looking pretty good. So here I've reached the logon screen and I'm now going to tap the touch sensor to bring out the fingerprint module. Since I've enrolled my thumb, once I place it on the sensor, it recognizes it and immediately retracts back under the desk. At the same time, the Pro Micro board sends a left click command to bring up the pin entry box and then types in 2291 in a completely automated fashion to complete the logon. And that's it. Thanks very much for watching, everybody. I really hope you enjoyed this video. Please let me know your thoughts in the comments below, and of course, don't forget to like and subscribe for more. I'll see you next time.